All right, hello everybody. My name is Maria Reyes, and the title of my ecological video project is Differences in Grass Growth at Hillcrest Cemetery. So yes, you heard that right. For my project, I observed an area of grass that was growing at my local cemetery, which might be a little morbid, but I guess I'll explain why I chose this. So the cemetery I observed my ecological phenomenon at was Hillcrest Cemetery, located in Porterville, California, which is my hometown. So the reason I chose a cemetery was because my grandmother unfortunately passed away in December of 2020. So I started visiting the cemetery more often. And while I was there, I noticed that a nearby plot had grass growing in winter while the rest of the grass was dead. So I questioned it, but kind of forgot about it. And then when it came time to think about the video project, I remembered that I had previously noticed this happening and decided to look into the ecological reason for this occurrence for my video project. So in these pictures, this is all I could find that shows the grass in the winter. This was a few days after she was buried. Here we can see the conditions of the grass in winter during the month of December. And in the circles, you can see what we are observing. So we can see that the surrounding grasses were pretty much dead and yellow, while the observed area is very green in comparison. So the videos I took were taken in spring, as that's when I started the video project. So the difference in the observed area to the surrounding area was much more obvious. You kind of see the contact there because the spring conditions were encouraging more growth in the entire area. They also started to water the grass again. They don't water the grass over winter as it's outside of growing season. So at the time of this project, they had recently started watering the grass. So you can see in the video an obvious contact of the thicker and taller grass compared, and then where this thinner and lower. And this was actually right after the lawn was mowed. So it's all been mowed down to the same height, but we can still see a difference. So here is how much it grew after about a week. You can definitely see a lot more of a difference. There's a good pan there. So we can see here it's thin and low, and then it kind of suddenly changes to tall and thick. So that's the ecological phenomenon that I observed. So when observing the area, there were a few environmental conditions that I immediately noticed that could explain why the grasses grew differently here. The area is pictured here, and it has the shade of a nearby tree. As you can see, this usually covers the whole grave plot area. This was just a time of the day where it hadn't reached that yet, but typically it'd cover kind of this whole grave. The area also has a very close proximity to a nearby sprinkler, and it appears to have a perfect positioning to hit the area directly. So if you imagine it kind of arching, hitting here, it kind of directly hits there. So this area kind of has a perfect condition in which it has consistent good shade and consistent good water. So with this information that I saw, I came up with my initial hypothesis, which was that the grass in the small area grows faster and taller compared to the surrounding grasses because of a perfect ecological condition. And by perfect ecological condition, I mean that the shade and water source of the area provides ideal growing conditions to the grass that allows it to grow much faster and taller than the grasses that are surrounding it that don't have the shade and water conditions. So in order to test my hypothesis, I created an experiment that would compare other areas with the same conditions to our initial observed area and see if the same phenomenon was occurring. This picture shows the block that I was looking at the cemetery. The purple circle represents our observed area, and these green circles was where I decided to look into. These were areas that had similar conditions of shade and sprinkler proximity. Right here, they're scattered like this because right here, there isn't anyone there yet, so they don't have the tree. So yes, after someone's buried there, they put a tree on top of them. So I guess effectively all these trees are a person, which is interesting. But so there isn't one there yet. So I didn't sample here. And then here there is a tree, but it's a different species with a different amount of shade. So it's inconsistent. So I didn't look at that. So I looked at all these. So for comparison, the video shows our area, which is here, and then one of the areas that I looked at that had similar conditions. You can see it's the same type of tree with the same shade and also has a sprinkler that would hit it directly. Now this kind of shows how the trees are located. That's our area here. So we see two trees across from each other and then a large low area. And then two more trees here. Here's where it will be in the future once someone's there. Another large low area. And then 2 more trees at the end here. This is the one that's different. You kind of obviously tell it's different. That's the one I didn't look at. But this pattern also repeats in the opposite direction. So in total in the whole plot, there was 5 that I looked at. So for the experimental design, I was only able to look at 1 week of growth as the cemetery has a weekly mowing schedule. The observational experiment was to compare other areas with the same conditions as our observed area and see if the grass was also growing faster and taller than the surrounding areas as it was at our observed area. The independent variable in this case was tree shade and water source proximity. The dependent variable was the grass growth rate. Some control variables were consistent mowing and water scheduling. A possible confounding variable could be the alteration by visitors, as I've seen some people water the grave area, some people cut the grass at the grave area. I didn't observe this while I was doing the experiment, but it could have happened when I wasn't there. So that's just something to consider. It could affect the experiment. The experimental unit is the area of grass covered by the shade of the tree, which is usually 1 grave area. And the number of replicates was 5, as there was only 5 other similar areas in the same block that I could look at. So this top video shows the same example area, which is one of the 5 areas that I looked at. This one was actually right across from our observed area, so it's arguably the most similar. And it was filmed at the time when the grass would have been at the tallest, as it was the day before the grass was to be cut. We can see that in this area, the grass isn't growing taller and thicker in comparison. It kind of has the same throughout as the surrounding grass, kind of low, thin, and slower growing. And this was observed at all 5 areas that I looked at, meaning that none of the similar areas has the grass growing like it did at our initial observed area. So therefore, the observations made in this experiment did not support the hypothesis. So as I was doing this first experiment, I made some new observations I didn't initially make. So this video shows what I saw when I was walking to the different areas, the different tree areas, and you can see that there's some variation in the grasses. So you can see tufts of grass popping out. There's kind of a uniform low grass growing, which is what grows typically throughout, but then you can also see big tufts of grass. And then some of these tufts of grass were similar to the grass that was growing in our observed area. So once I made these new observations, I formed a new hypothesis. So this new hypothesis was the observed area contains grasses that survive over winter conditions and grow faster than the surrounding grasses because the grass in the area is a different type of grass than the grass in the surrounding area. So now I was thinking that the grasses that are growing at our initial observed area are of a grass type that can survive over colder conditions and grow tall, thicker, and faster. The grass of the surrounding area was just simply a grass that cannot survive over colder conditions and grows thinner, lower, and slower. So for the new experimental design, I looked at the grass type of our observed area and the grass type that surrounds the observed area. The independent variable in this case was the grass type, and the dependent variable was how the grass grew in terms of speed, thickness, and height. The control variable was the consistent mowing schedule. Some confounding variables now included the shade of the tree as that can have the possibility of making the grass at our location grow more or less than it would without the shade. And the surrounding area does not have the shade, and there really isn't a way to kind of change that. Watering may also be a confounding variable as the water hits our area consistently, but hits the surrounding area differently. So that could also affect the 2 grasses growing potentials. Our experimental unit is the same area of grass covered by, I guess, the grave area. The other samples were taken near the initial area where there was an apparent different grass type, but also at the approximate size of the grave area. There were 5 replicates of each grass type, meaning that 5 samples of each grass type were taken to make sure it is representative of the grave area. So in total, 10 samples. So here are some pictures of some of the samples that were taken in an effort to identify the grass type. The grass type of our observed area was identified as tall fescue, just these taller grass blades. This is a popular grass used in Southern California as it's tolerant in higher temperatures. Some identifying factors are the blade is usually a green to dark green color. It grows in a rolled shape, which you can kind of see here. The tip of the blade is pointed and the width of the blade is thick, and it grows in bunches like we saw in the video where I was walking around. So then the grass type of the surrounding area was identified as Bermuda grass, which are these short stalks here. This is also popular in California as it's a warm season grass. Some identifying factors are the blade is a lighter to green color to regular green color. It grows with a fold in the middle. Can't really see that, but basically the blade has a fold in the middle. The tip of the blade is pointed and the width of the blade is narrow, especially compared to the other grass. And it spreads horizontally when it grows as opposed to how the fescue grows upright. and in bunches. From these new observations, we can determine that our observed area has a different grass type that naturally grows taller, thicker, and quicker. Therefore, our new results support our revised hypothesis. The grass type also is classified as a cool season grass, which explains why it was still alive in the winter compared to the surrounding grass type that is a warm season grass that doesn't survive in the winter. And even though it is a cool season grass, it still survives in the summer because it can tolerate higher temperatures, which explains why it was growing well despite being a cool season grass located in an area that has warm temperatures, albeit the temperature hadn't gotten too hot at the time of the experiment. So now to try to explain why there are different grass types in the area, it's likely that when the grass was planted, a seed mix was used, of which Bermuda grass and tall fiesco grass are common in those mixes. If the seed mix wasn't used, it's possible that the cemetery bought rolls of grass turf. In this case, it would be all one grass type, likely Bermuda grass, since that's what's mostly seen throughout the cemetery. So the different grass types could have come naturally from surrounding areas or from visitors to the cemetery unintentionally, say on their shoes brought from their own lawns. So there are some things that could be changed to the experiment that could make an improvement to the experiment. Ideally, we could eliminate the cutting schedule so we could observe a longer period of growth and determine more of a difference. And we could also measure the rates of the growth to compare each type more readily. However, that is difficult to do as I can't change the mow schedule or stop them from mowing in the area. And I also couldn't come back to measure the same shoots as I could try to mark them, but the marks would be taken down as they're pretty diligent about taking things away that aren't placed on graves or meant to be on the graves. Something else that could be useful would be to take soil samples of where the grasses grow to determine if there's a difference in the nutrients that could aid or diminish how much a grass grows. However, that might be taking it a little too far, as we would have to take at least a foot deep soil sample to be able to accurately get a soil composition. So that would involve digging a foot deep on top of a person. So past it being disrespectful, I would also likely get kicked out by the cemetery workers if I were to dig on top of a grave. But ideally, getting those soil compositions would be helpful to determine how the grass is growing. And finally, data could be more representative if it was taken year round. However, the time constraints for this project don't allow for that, but it could be something that I could look at doing in the future since I will be in the area anyways. This is my works cited that the sources I use to help identify my grass type. And that's the end of my presentation. Thank you so much.